Hello everyone, this is Saqib Khan from the Spannovation Bridge and Seismic School. I wanted to talk to you today about something that has more of an overarching philosophy to it. And my topic of discussion today is the analysis design cycle. And through this I wanted to speak to you and give you some of my philosophical musings about something we do on a daily basis, but a lot of the times when we're starting out in our careers, it's a little bit of a tricky thing to keep in mind. And I remember when I started, I was a little bit confused about the whole thing. So the way the analysis design cycle really works is we start with our analysis, whether it's by hand or we use the computer software. We put our structure into it and we analyze for different load cases. We get the demands and then we go into designing. And in a simple world, what that means is we're basically checking the capacities of the members. So we might be looking at the thicknesses and depths of sections and flange thicknesses or reinforcement ratios or pre-stressing quantities in our girders or deck, looking at our columns and cap beams, etc. And what comes out of that is, for each member, we come up with the D over C ratios, the demand to capacity ratios. And if for all the members those are less than 1, then we say it's tickety-boo, it's good, we're okay, and we can stop. Or if we find that the D over C's are on the lower side, say, the numbers are earning up consistently around 0.6, 0.7, 60 to 70%, then we know that there is a bit more meat in the system and we would like to optimize and have some material savings. We make some changes, we go back with the new system, the new sizes we analyze, and hopefully we've just optimized it enough that now these are sitting close to 0.9, 0.95 to have the good design that we've been looking for. The flip side is that when we run the D over C checks, that they end up being bigger or larger than 1, in which case we know that our members are not adequate or appropriate for the loads that they have to resist. So we now go and make changes. We might be thickening our sections, we might be putting more rebar or more pre-stressing or more steel in our girders or columns or what have you. We reanalyze and we go through this cycle all over again until we're satisfied. But the question is, when I'm starting off, what am I analyzing? What is being analyzed initially? It's starting this cycle that can be quite tricky for young engineers if you're just given a problem. Like if I am starting off and I'm given an open site plan and say, hey, please design this bridge, I will be at a loss because I haven't done it before. I have very little engineering judgment. I may not know the rules of thumb, and my sense of proportioning might not be developed very well at this point. So I wanted to bring this whole discussion to this point where what I want to emphasize to you is that developing a sense of proportions is very, very important. And the earlier you do it in your career, the better off you're going to be with trying to answer this question of where am I starting? Usually the world is not that cold and cruel. Your supervisor will give you some initial sizing to start the cycle. But as you get better and better, you want to be able to have a sense of proportioning so you can be the instigator, the person who's starting the design or the analysis of your structure with a system which is already well proportioned. I remember when I was in the first couple of years, I was looking at a bit of a complicated problem. This was a rail crossing in some marshland, so the design was basically to drive steel pipe piles and then put a thick 600 or 700 mil thick slab on it for rail loading. And the geometry was really governing in that case, so the skew on the slab was about 60 degrees. And I did different analyses and drillage analyses, ran my loads and looked at different combinations of the moment this way and that way and torsional moments and combined them. It took me about a month. Ironically, at the start of the of my exercise. My supervisor, who's very, very smart and has made a name for himself in the engineering industry, basically went into his room, sketched something up within about 45 minutes, and a month later when I showed him his design, he pulled it out of his drawer and our answers were pretty close. So what took me about a month took him about 45 minutes to get to. So what I'm going to impress upon you again is develop a sense of proportioning. There are rules of thumb available, which we will be discussing in our upcoming courses, and then as you do it more and more, you start to develop this engineering judgment. So once you start off with a rather reasonable solution where the sizing and the proportioning is in the ballpark, it's much easier to start the cycle and go through it. Thank you very much for listening to me today.